This is Walter back with Mr. Chris Cunningham. We are going to show you how to use the handheld mechanical splicer. What's the number, Mr. Cunningham? What's the model number on that thing?
This one is a TL-UCP.
And it's one of the model numbers by Corning. It does have a ferrule adapter right here. Then we have the cradle that is going to hold the connector in place. We have the on and off switch because this is a battery operated, it needs to be powered device. The reason for this device to be powered is so we could inject a light into the connector that we're using. Now we have two LEDs. One is the green LED right here, and then we also have the red or orange LED that those two LEDs are serving as indicators. Basically, if the green light is on, that's what we want. It indicates that everything is all right, everything is okay as far as light passing through the connector, through the ferrule, right into the fiber optic. If something goes wrong, maybe some things are misaligned or whatever reason, the green light is going to go off and we're going to have the red light blinking, indicating that there is an error. Also, the splicer has a load button right here, and we're going to demonstrate those. And it has a, what is the other button? The camming button. All right. Now we also have a reset button, but don't press it yet, Mr. Cunningham. Yet we're just going to make the view a little bit bigger. This reset button operates the cam section right on the splicer. So that's basically the overall visual on this. The connector goes right in this, is going to be placed right in this area right here. Then the ferrule adapter is going to go down to hold that, and the ferrule adapter is going to go on top of the ferrule of the connector. It moves up and down just like that. And that is going to serve as light injector for testing purposes. It's basically a self-testing unit as we go. This is not a signal tester. The purpose of this self-testing is just to show or just to verify that the splice is being done correctly. And then if you really want to test the connection or the signal loss on the connector, then you need to, what needs to be done is that the signal meter has to be applied after the connection has been made. Okay, so that's the overall view on that. I'm going to swap the camera here, camera view, so I'm going to make that that camera bigger, and I'm going to turn my camera off just so the other camera view is much bigger for the video purposes. So I'm going to unshare my camera. Now we have a big view right here. All right, so Mr. Cunningham, we have the, can we just show the operation of the cam and see if I can, I cannot use the pointer, so Mr. Cunningham, you're going to have to point that to. So the cam action happens. This is the camming button, and that operates. Let's just see the camming button first. See, that just turns that section. That it's called a cam. It just turns it sideways, and the purpose of that is to turn the cam right on the connector. Can we see the cam on the connector? Once that connector is inserted, that is the piece, that little square piece that is going to turn as the cam turns on the splicer. So the part of that turns the cam on the splicer is called a cam, and also the part that is being turned on the connector is also called cam. So if we press the reset button, it's going to reset that camming that action on the splicer. All right. Okay, so let's just take a closer look at the load button. The load button is going to move the ferrule adapter up and down. So if we press that, that's going to make, sorry, that's going to move the cradle. The cradle is, the purpose of the cradle is to align the, is to place the connector. And then the ferrule adapter is going to go on top of the ferrule. So see the action of the loading button. Okay. Now the loading button is momentary, it's spring loaded. So once you press it, the cradle goes up, and once you release it, the cradle goes back. The the cam button is it's locking. Once you press it, it's locked. Okay, and you have to press reset button in order to unlock the cam to be ready for a connector. So if we can press the reset button, okay, let's take a closer look at the connector. All right, so here is, what type of connector are we dealing with? That's the LC, is it?
This is a Corning LC connector. It's a
LC.
50 micron Corning LC connector.
Okay, 50 micron Corning LC connector. So this is the multi-mode, because 50 micron stands for the core, 50 micrometers or 50 microns. And what do we have? Let's see the ferrule. The ferrule is a tubular device that extends from the front right to the rear of the connector. So that little white piece that sticks out at the front is the front of the ferrule, and the piece that looks like metallic kind of a piece, it sticks at the from the rear there, that is also part of the ferrule. The ferrule goes, it's a continuous tubular device that goes right from the front to the back, and that's where all the magic happens as far as the fiber strand connection. Everything else that surrounds that serves as housing, and it's designed to either hold the fiber strand in place, or also it's designed to be insert that into the patch panel that is in the fiber tray. Okay, so the metallic piece of the ferrule, if we could just leave it off for now, that is going to be crimped once the fiber gets inserted from the rear inside that tubular funnel type of a funnel shape opening there. Then after the splice is complete, that metallic piece is going to be crimped. It's going to be squeezed. So the fiber strand is being held by the buffer in place. Okay, so now okay, also we're going to we see the dust covers from the back and from the front. So the ferrule needs to be protected. And the reason for that is that we are dealing with microscopic sizes, and 50 microns, or maybe sometimes smaller, 10 times smaller. What is it? Common sizes for the single mode core. Is it 9 microns, 8 microns? Mr. Cunningham?
Yes, that is correct.
Yeah.
As low as 5. It can go as low as 5.
As low as 5 microns as far as the core. Now, when we're dealing with sizes that small, then dust particles come in play. So I remember, Mr. Cunningham, you were giving a lecture a year ago. I was sitting in on your class, and you mentioned that dust particles are very close in size to the core, especially in the single mode, multi-mode as well. So also that front part of the ferrule is some form of a PVC or glass type.
It's actually ceramic.
Or ceramic, which means that
ceramic.
Yeah, which means that it can be statically charged, and if it's statically charged, then it could attract dust particles. So we need to make sure that as much as we can, if we can help it, keep the dust cover on. So there's very little chance for the dust particles to be attracted, because a dust particle can blind the connector actually. Okay, all right. So here we have the connector, and we have the. Now we're going to take a look at the fiber strand, or the fiber cable, or the fiber strands that are part of the fiber cable. So. All right, so we see a yellow jacketing on that, so that should tell us that it's a single mode, is it?
That is correct.
Okay, now we have another cable here, that's aqua. Aqua stands for multimode, is it? That's for the 50 microns multimode?
That's right, 50 micron.
Okay, nice. And over here, also we see from the jacketing, we see the pieces of Kevlar. Kevlar. So it's so we can tell that because that we can see this Kevlar. This is what type of cable is that? That's right, you got it. It is tight buffer cable. Okay, so all the fiber strands are tightly packed and surrounded by the Kevlar strands for protection, physical protection. Now that Kevlar is this is the same material that's used in the bulletproof vests to stop the bullets from penetrating the bulletproof vest. So it's a quite rigid material. That usually that Kevlar is being usually after the cable is stripped, that Kevlar is being cut off. Sometimes it's using as a strain relief. If you want to provide extra protection from people yanking on the cables, so it's tied by the Kevlar, somewhere to the trays or in the patch panels. Right. So now we have how many strands of fiber do we have? One, two. Sorry.
This is a 6 strand.
6 strands. Okay. And we studied the color codes: blue, orange, green, brown, slate. Do we have that? No. What do we have?
Yep. Blue, orange, green, brown, slate, and white.
And white. So that's the numbers of the strands. Okay. So what would be the proper sequence? First, we would prepare our handheld device to be ready, because once we strip the cable, then this cable is going to be, or the fiber strand is going to be vulnerable. So we want to have everything ready. So press the reset to the now we're going to raise the cradle and insert the connector. So the ferrule goes right, sticks out right from the back. Let's see the rear here. Okay, so the ferrule sticks out right there. Good. Now, do we see the red light coming out of there or not yet? Okay, if we turn it on, the light is going to be injected from the ferrule adapter, by the ferrule adapter. So we should be able to see. Okay, so here's a green light on the LED. And then once we close that ferrule adapter and close the flap, now if we look at the back of the ferrule that's sticking out, you see the light is already being injected into. Now we shouldn't look at this thing straight with our bare eyes, although this is not a laser, is it, Mr. Cunningham?
No, this is just a strictly LED.
Strictly LED. I would still try to not look there because the light is still quite strong, so it's not going to blind you like a laser, but it still can damage your eyes. All right, so now we have the connector prepared and ready to be spliced in the mechanical splicer. Okay, now we're going to proceed with the so what we're doing here first.
So this is the booting process.
Okay. And the reason why we do this is that after the whole thing is spliced, the connector is spliced, we won't be able to insert that later. Right? And then, so basically, the sequence of putting things on is going to vary from a connector to connector. So before you start doing series of connectors, I would strongly recommend reviewing the procedure recommended by the manufacturer. Okay. All right, so now we are ready to start stripping. So first, we're going to use the stripper, the fiber optic stripper.
We need to measure first. There's going to be 2 marks.
There you go.
This is the fiber guide. We're going to measure the first one to 40 millimeters, and then the second mark is going to be at 11 millimeters.
Okay. And we're going to use the wonderful permanent marker that is supplied right in the kit.
Right here. So we can do, it would go this way, put it into 40 millimeters, mark it once at 40, mark it once at there. So now that we have our mark at 40 and 11, we know that we can take this and we can start to strip.
Okay, so first we're going to use which groove for that? Excuse me.
This will be, as you can see, there's 3 grooves in there. See the 3 grooves? Because we've already got the jacketed stripped, we're going to use the middle groove. And that's going to take off the sheathing here, this plastic coating, the PVC coating.
Okay.
So you can see here.
And sometimes we do it in stages, right?
Yes. And it comes off. You can see how I peeled that off. Now we're just down to the fiber, but that cladding that's on the fiber. So we discard the garbage.
That's the buffer, right?
That's the buffer, yes.
Yeah.
So then now we're going to move to the smallest groove, which is the little one at the very end. And we're going to take it right to the buffer, right at the end of the jacket, and clean it. And as you can see now, on there, there's a little bit of residue.
Yeah, that's the buffer that's being stripped away.
Now, right now, we're down to bare fiber right now. See if I can get the light to shine on it properly. There you go, a little bit. It's better on a black surface.
It's hard to see.
Let's do this.
There we go. Let's see here. Can we? Oh yeah, there we can see a little bit of the fiber. Now
Now
this, yeah. So this is a stripped fiber, and but still we are not done preparing it yet, because what is the next step? The next step is going to be cleaving.
Well,
right?
we're going to clean it first.
Mm-hmm.
We need to take alcohol.
Mm-hmm.
This is a fiber optic. This is a fiber optic cleaning fluid by Corning. This is provided by Corning. And you take a few squirts out of this. Now my rag is soaked. And if you listen closely, you'll hear it squeak. I don't know if you can hear that. It squeaked twice for me. So
Okay.
I know that is a clean fiber right now. Okay.
Okay. So now I wonder if we could just open up that cleaver and just see what's inside. All right, so what do we have? With the blue button on top, that's there. Once we press that, it's going to lower the diamond blade. Actually, the diamond blade is right on the bottom of the cleaver. You can see that black slit right there, right inside there, and that is going to push the fiber against that diamond blade, and it's going to score. But first, we are going, after this fiber is inserted, we're going to press the red button in order to present a tension. So once the button is pressed, the tension is on, and then after the tension is on, we're going to lower the fiber right onto the blade by pushing the blue button from the top. So that's how it works. Okay, let's see if we can insert that. Did we make the fiber dirty again?
Well, it should be fine. It's
okay.
safe. It's safe.
All right. So now we're going to insert the fiber into the cleaver. We need to press both buttons. So by pressing both buttons, we are opening the channel. So we could insert the fiber, and the other end of the fiber should come up the front. Right.
The tiny little of the front.
Yeah, it's hard to see, but trust me, it's there. Yeah. Now, after we release those two buttons, then the fiber is being held. Then we're going to press the red button to present tension, and just press it once, and then press that blue button, kaboom, and the fiber is being cleaved. Pressing the red button presented a tension, and pressing the blue button lowered the fiber right onto the blade. So now this is a cleaved fiber, and remember, the purpose of cleaving is to provide a straight edge at the tip of the fiber, so in order to make that fiber actually spliceable. Otherwise, it's just broken piece of glass and it's shattered, and we can't splice it because we cannot align that to anything. So now we have a straight edge, nice and clean cut. Next thing, so now we have this connector prepared, and we're going to insert that right into the ferrule until it stops. And you go by feel. Usually, after a few times, you're going to develop the feel for it. Okay, so now the fiber is inserted into this into the ferrule, and then we're going to, yeah, there we go.
Need to pay attention.
So if you push slightly, that at its own spring-loaded tension, it's going to pry against whatever it needs to touch inside the ferrule. That means we have a nice budding against whatever it needs to be budded there. Now we're going to press the blue button, and it's going to lock. And remember, that turns the cam. That is turning the cam right on the connector, and by doing that, we are locking that fiber optic strand right in the connector. Okay, and then what we do is we turn this. Okay, so when we turn this, we could turn this thing multiple times. We recommend that it's turned once. What happens is that right inside where the metallic ferrule is there. Let's just see where the metallic ferrule is there. Yeah, you could see two black jaws. So when you turn that green knob, those jaws close onto each other, and therefore they're crimping. There you go. See, they're closing and they're crimping that rear part of the ferrule just to hold that in place, the fiber optic strand. Okay, now what we're going to do is we're going to verify that we have green light, right? And the light is green. That means everything is fine. So now we're just going to raise the cradle by pressing the black button right there. Raise it, and we're going to, now we can just remove the connector from the cradle. And what is the first thing that we're going to do right after removing? We're going to put the dust cap on, just so no dust particles are going to be attracted to that ceramic part of the ferrule. So we have the dust cap on. There we go. And whatever the procedure is later on, we're going to put the other housing parts to provide strain relief. And as I said, this is this type of connector. 2 years later, somebody else is going to invent another part of the connector. So we remove the helping pieces that are helping us to hold that in place when we're using the splicer. And now we have a finished product. This is a single mode LC connector being mechanically spliced right onto the fiber strand. So this is how we do the mechanical splice. Right. Is there anything that we need to add, Mr. Cunningham?
No, I think once you get used to doing it, they just fly through. Each one of these connectors takes about 2 minutes, maybe. And then so you can get used to doing it. So you got 6 here, so you can figure you get about 15, 20 minutes and you're good to go.
Yes. And those connectors are being plugged into the fiber optic version of a patch panel. So that could go into other equipment, or they could be extended with other fiber optic cables, whichever the procedure is that you need to do. Usually, these type of tight buffer connectors, they are meant to be used inside in the LAN configuration on premises. And usually they're being used to connect distribution frames. So there could be a distribution frame connecting Cat5e cables right to the desktop in one spot of the building, and there could be another distribution frame connecting a bunch of other end users, computers, wireless access points, whatnot, to the closet using Cat5e cables. And those closets can be connected to each other with these tight buffer cables that are meant to be inside. And
Now,
that's
don't
okay.
forget, we have the loose fiber still in here, so we have to remove it by pushing both of these together, grabbing this fiber. I have the fiber in my hand. It needs to go into a container like this. Drop it inside. Make sure it's not in your fingers. Now we know that the fiber is inside of here. I can see shards of fiber inside. This is what we keep all our fingers, all our eyes safe.
Mm-hmm. Okay, so and then so you say 2 minutes. It takes about 2 minutes once you're experienced to do one of those. So sometimes that's all you do for the whole day, or sometimes it's part of the bigger job. It's not only one thing that we do in the field of data installations or data industry. We run copper cables, and then we run fiber optics. So we need to know, well, not everything, but there's various fields of network cabling that is involved in installing networks. So the most important things that we have here, we have the cam splicer right in the middle, the big piece of equipment, that's the biggest one. Then we need to have a cleaver. Cleavers come in different shapes and forms. This is, if you want to see cleaving or different type of cleavers, by all means, go on YouTube and see how many, I'm not sure you can count how many different types of cleavers humanity has invented to make our lives better. So here's the cleaver, and the purpose of the cleave is to make a straight edge at the tip. Then we have the connector. That's the expendable part because we just keep going. We have to order those in order to just keep ordering, and all the rest is not expendable. It's our tools. So then we have the fiber optic stripper and the cleaning solution. Or if you could have you could use isopropyl alcohol as well. And then we have the cleaning rags or swabs. They are specially made for fiber optics. Now, the way that we use that, we make a V-groove, and once this thing is wet with the cleaning solution, and that's how, and we only touch that with our fingers, which that we touch the outside part. We never touch the inside because we still don't want to introduce the oil from our fingers, which can also obstruct the light transmission. If one of the rags falls face down on any surface, then it's unusable. Just throw it out and grab another one. In a nutshell, this is how we perform mechanical splice. I'm not sure if we're going to be able to get the fusion splicer in order to do another demo like this. Chances are that we won't be able to get that. However, when the whole thing is over, please come and see us, send us an email. We will make time for you if you're really interested or you need it for your job or whatever reason that you might be. Okay. All right, Mr. Cunningham, anything else that we need to
I think we've covered a complete, clean, and safe termination of a fiber connector.
Okay, and don't forget to use your PPE, personal protective equipment, while doing all this. Safety glasses. Some people recommend, in some cases, going to be recommended using gloves, latex gloves, because of if you're in contact with all the chemical solutions and things like that, you might develop some. Not develop, but it could be harmful to your skin if it's prolonged use. And what we have here, that's the Corning ruler, I would say, or the visual guide to help us with some measurements, because different connectors require different markings to serve as indicators for lengths. This was the demo on how to perform a mechanical splice using a Corning mechanical splice kit.